Hello, dear learners. I welcome you all to the 9th module, that is Earthing of the SWAYAM MOOCs on electricity and electrical wiring. Module 9 has been divided into 3 units, namely earthing and its requirement, secondly process of earthing and soil resistivity, and third video will be on types of earthing and their advantages and disadvantages. In this lecture, we'll discuss about earthing and its requirement. In this lecture, we'll cover the following topics. First, we'll introduce ourselves to the definition and the scientific meaning of earthing. After that, slowly we'll try to understand the science of earthing. Then, we'll discuss about the difference between earthing and grounding. And towards the end, we'll also discuss how to protect ourselves as well as our home from earthing with example. And finally, we'll conclude by discussing some precautions to be taken while earthing or grounding. Let us start our discussion now. The process of grounding or earthing is one of the most important part of electrical system, which is basically related to safety and reliability. It consists of establishing a dependable and firm connection between the non-current carrying part of a power grid or its neutral point to the ground. Any excessive amount of current resulting from electrical fault conditions shall be expelled and discharged into the earth through this earthing connection, which is actually inbuilt in the facility. And this prevents the associated risk of electric shocks, risk of outbreak of fire and damage of electrical equipments from being overload sustained. Earthing is not merely a technical necessity, it is one of the most important safety precautions to be taken within electrical fittings. This procedure includes the dispersion of excessive amount of current, and the sole purpose of it is to save a person from getting in connection with electricity or getting hurt. Grounding minimizes the risk of associated with electrical fault by linking electrical system and appliances directly to the earth. So this procedure enhances the overall safety of the environment in which this system operates. Let us now discuss in details about earthing and its requirement. First, we will consider the formal definition of earthing. So what is the formal definition of earthing? Electrical earthing is the process of using a low resistance wire to send the quick discharge of electrical energy straight to the ground. Connecting the equipment's non-current carrying components or the supply system's neutral to the ground completes electrical earthing. Now let us talk about the science behind this earthing process. The intrinsic topic of earthing or grounding encompasses fundamental concept of electricity and magnetism. There are some very common terms used in physics such as conductivity, electric potential, Ohm's law, charge distribution, etc. And these are associated with the process of earthing. First, let us discuss about conductivity. So, our earth serves as an excellent conductor of electricity, allowing the transfer of electric current with minimal resistance. Connecting the electrical system to the earth enables the safe discharge of any surplus charges in the system. And what is electric potential? The earth is recognized to have zero electric potential. Connecting any conductive component of the electrical system to the earth maintains a consistent potential, averting any dangerous potential fluctuations. Now, what about charge distribution? charges or electrons, means electrons are charged particles, charges migrate from regions of high potential to those of low potential, and it facilitating the flow of excess charge to the ground during a fault condition. So therefore equalizing the potential. Okay, so let us now discuss about some operating terms that are very used in discussion of earthing. First, fault current path. So this term actually very much used. In the presence of a fault, such as a short circuit, the current deviates unexpectedly. Earthing provides a direct, low resistance path for the fault current to dissipate into the earth, and it mitigates fire or electrical shock risk associated with the system. In case of any fault, the fault current will be dispersed safely through the electrodes into the earth, and it is called grounding, and in this process, in this way, it eliminates all possible dangers. So here in this diagram you can see that the person is touching a appliances, say it is a any electrical instrument, and if it body contains excess amount of current due to some fault, then all the current will get passed through this human, and in that process the person will get hurt or shocked. Okay, now next point that is very much common in earthing is grounding of electrodes. So this includes conductive elements like rod, plates or wires embedded in the earth to establish a direct connection, enabling the dispersion of fault current into the ground. So these two terms, fault current path and grounding earthing, these terms are very commonly used in the process of earthing. Now another important physics theory that is used in earthing process, that is called Faraday's law of induction, and how it is connected to earthing, let us understand this first. The fundamental principle of electromagnetic induction that comes from Faraday's law, and it forecasts how an electric circuit will interact with a magnetic field to produce electromotive force, which is shortly called EMF. So moving from the battery's positive end to its negative end requires effort from the per unit charge, which is known as electromotive force or EMF. As you move from the battery's positive end to its negative end, you will also think of it as the energy gain per unit charge. Now current flows in an external circuit due to the electromotive force, and it produced by the battery or electric generator. Earthing is connected to electromotive force. How? An electric system fault like a short circuit might result in the EMF causing a significant current to flow through the device unexpected way. Now earthing gives the fault current a secure way to go to the earth. Take for instance a battery operated device. To push the current through the circuit, the battery supplies the EMF. Earthing guarantees that the voltage is securely discharged into the ground, preventing electric shock in the event of malfunctioning of the device. Now let us discuss about some essential components of an earthing system as a whole. First, earthing conductor. These are cables or wires that links the electrical system to the grounding electrodes. So what is grounding electrode? So grounding electrode provides the path for the fault current to pass through the earth. The pathway is enabled by the earth plate, also referred to as the earth electrode. The earth electrode is one of the most important elements of electric earthing system, which facilitates the safe dispersal of electric energy. A metal rod, plate or similar conductive object buried in the earth is providing as a grounding electrode. Next, another important component is earth resistance. So how earth provides resistance? The efficacy of earthing depends on the resistance between the grounding electrode and the ground. Lower resistance enhances grounding effectiveness, influenced by factors such as soil moisture, temperature, and composition. Okay, so let's also discuss about the difference between earthing and grounding. While earthing and grounding are often used interchangeably, they do have some differences between them. And based on their purposes, let us discuss the differences one by one. First difference is components connected. Let us consider what components they connect and how they affects. So while grounding connects current carrying components, earthing connects non-current carrying components. For example, consider a transformer. Its neutral has been connected to the ground, which carries current. So when we connect the current carrying material directly to the earth, it's called grounding. Now, instead of that, if we connect the body of the equipment, say a motor, to the ground, then it is called earthing. In earthing, we protect both the equipment and human from sudden shock. Next, discuss about the functioning between earthing and grounding. So the main purpose of earthing is safety, while that of grounding is to stabilize system with protect equipments. When we say safety, it means protection to human. So purpose of earthing is to protect human from sudden flow of current through human body. While in earthing, we talk about the safety of equipments or machineries. For example, in case of a transformer, we connect its neutral to the ground to prevent damage of the transformer during sudden passes of high current. Now, another difference is the reference point. Grounding stabilizes an unbalanced electrical system. For example, consider a three-phase transformer where all the three loads are different. Then the system is called unbalanced system. So connecting the neutral of such transformer to the ground provides balancing of the system. But there is no concept of balanced or unbalanced system in case of earthing. It's purely done for the purpose of human safety. So at this stage, I hope you will be able to answer the following questions. Now, all of us generally have earthing done at our home. Let's understand how it protects our home as well as other electronic devices. Large buildings can suffer greatly from the natural phenomena of lightning. I am sure that all of you know how lightning occurs and what harms it can cause to us. During stormy season, there are often reports of fatalities from lightning strikes. In addition to the obvious effect of lightning, a voltage spike can harm home electronic devices. For our houses and other structures to be completely protected, earthing is therefore very essential. Equipments for lightning protection that has been developed and tested in accordance with the highest international standard is now available, and we can use them to protect ourselves from lightning. So these instruments are called lightning protection system. So here in this image you can see electrical power system has been earthing or grounding has been done here, and you can see that whatever the excess current that will caused by the sudden spark of lightning, that will pass to the ground through this connection. Similarly, in this picture, you can see a home is affected by lightning, but there is a lightning protection device installed at the home. So you can see a outer rod facing to the sky, which collect all the current, all the excess current generated due to lightning, and it provides safe passes of that current to the ground. Thus, during the monsoon season, the lightning protection system serves to shield the building and its occupants from lightning strikes. Your home may sustain sufficient damage if lightning strikes it, and in such a scenario, a fire may spread throughout the house and harming both the structure as well as its occupants. The lightning protection system is made up of rods and a few cables. These cables are copper cables and have a grounding protection device attached to them. When lightning strikes the house, the rod and wires help to send the lightning's current to the ground, and in that way protect the house and its occupants. So this system is also known as protection system or lightning protection system, as we have already told. So to put it simple, when lightning strikes the sky, such iron rod collect the lightning current and send them to the ground. As a result, the house and its occupants are safe, and it works incredibly well on huge buildings. Now let us discuss how to construct grounding system. The IEEE standard states that materials like copper and steel are used to make grounding rods. The earthen electrode itself is typically made of some conductive materials and is located deep within the ground to reduce resistance level. There are a number of selection characteristics to consider when you are selecting a grounding rod, including its conductivity, corrosion resistance, and diameter based on fault current. Copper bonded, stainless steel, solid copper, and galvanized steel grounds are some of the varieties made from the copper and steel, which can be used as grounding electrodes. So depending upon the requirements of the site, it can be in the form of a rod, plate, or a pipe. Chemical grounding rods with natural electrolyte salt for low impedance grounding have been produced in recent decades. In addition to that, some additional materials are also used in the grounding process. So these materials, when combined with cement and water, this high performance, low resistance earthen compound creates a strong electrically conductive concrete that will survive the system's lifetime. We'll discuss about different types of earthen in a separate video. In order to improve the overall performance of the earthen system, a number of suggestions and recommendations must be taken into consideration. First, resistive levels. In the ideal world, the value of the resistance of the earthening wire has to be preferably zero. While a zero resistance value is practically unrealistic, so it's a good practice to aim to get at least 1 ohm or with a maximum target value say 8 to 10 ohms. This low resistance will ensure that the current easily passes to the ground. Next, electrode orientation. That is very important. The proper installation of the earthen electrode is very important. So one has to definitely ensure that these electrodes are variably secured in a vertical position while you are installing them in your site. Third important point is distance. The distance between the earthening electrode and any electrical installation fitted should not extend beyond 1.5 meters. This limitation is required to make sure that the path for fall current is as less as possible. So in this way, we can reduce the resistance and hence can increase our safety. Since electricity typically flows through the electrical device load during regular operation, it is normal to wonder why such comprehensive grounding system is necessary. But the primary goal of earthing is to protect people and gadgets against any electrical shocks. So, an improperly earthen system always poses a deadly risk of electric shock. As an example, let us take a case when some person touches an electrical device like a switch or an appliance when the same is not properly grounded. So in such a scenario, as there is no proper path for a fault current, the person may die because of electric shock. In such situation, all the fault current will pass through the person who is touching the appliance. So here in this picture, you can see that the person is touching an appliance which is not properly grounded. And because of that, all the fault current is passing through this person and hence through the person it is going to the earth. And it will cause surely damage to the person. So how much damage it will cause to the person? Let's discuss this. Let's look at this electrical setup which comprises the different electrical equipment and live wire. Electrical current is supplied to the gadget by the transformer. Let's examine the situation now. First, let's say that the electrical equipment is operating at a voltage of about 600 volts. Now, let us apply Ohm's law, which states that the current flowing through a wire is directly proportional to the difference in potential applied across the wire. That is, the formula for the current is I equal to V by R. So, if the resistance of the device is 100 ohms, then as per the Ohm's law, it will cause a current of 6 ampere that will flow through the apparatus. However, situation like an insulation failure can arise which present a significant risk to a person. When the insulating material that keeps live electrical conductors away from the earthen portion of the electrical system breaks down, it is referred to as insulation failure. So in such case, there can be an inadvertent connection formed between the live wire and the material body of the machine. This connection enables leakage current to flow through the equipment, and that current, in addition to the original current, can travel through the load. This failure could lead to dangerous circumstances or possible catastrophic consequences. We'll discuss the cause of such failure towards the end of this lecture. Also, what precautions have to be taken in such situation will be also discussed. Let's get back to the example again. The current can now pass through a person's body if they unintentionally touch the equipment's metallic exterior. The human body has an average resistance of about 1000 ohms. Therefore, the current that would pass through a person's body in this scenario can be computed using Ohm's law. So, it is 600 volt divided by 1000 ohms and it gives you approximately 600 milliamperes. Given that even exposure to about 150 millimeters current can result in a severe electric shock. So this 600 milliampere currents can harm or make a person die. So this is an enormous number of current. So from this analysis, I hope that the importance of earthing is now clear to you. I hope now you will also ensure that your home have proper earthing installed. Now, the key question needs to be answered is how earthing shields the human body from electric shock. An electrical system diagram that is correctly grounded might be used to show this. Here we can observe that an earth wire has successfully connected the electrical equipment to the ground. Proper grounding ensures that any leakage current goes away from the human body if a human touches the metallic body of the instrument. In such a situation, instead of passing through a person, this current will travel through the earth wire directly to the ground. The earthing system utilizes low resistance wire for this purpose. Let's say the resistance of the earth wire is approximately 1 ohm compared to the 1000 ohm of human resistance. So current will naturally follow the path of low resistance to the ground. This method effectively protects people from electrification. So in many places, MCB can be utilized to reduce the risk of damage to the equipment caused by current traveling through the ground wire. This safety device offers an extra layer of protection as it cuts out the current whenever it detects leakage current. Although electrical appliances like refrigerator are excellent conductors, they depend greatly on proper earthing system for safety. Because of this, as we keep exploring this important part of electrical security, we need to understand the various types of electrodes used in these systems. However, the complexity of this system can sometimes be overwhelmed. How does an MCB protect us from short circuit or current overload? MCB can be a good option for the consumers to add to the electrical circuit, as it can protect from sudden overload or short circuit of the device. It can protect our circuit as it keeps monitoring the amount of current that flows through the circuit. If the amount of current exceeds the permitted value, it will automatically disconnect the circuit to prevent any further damage. MCB use a special strip made up of two metals with different expansion rates to guard against overloads. When the current in the circuit becomes too high, this strip heats up. As it warms, the strip bends, and which activates a mechanism that trips the MCB to cut off the power. MCB are fitted with an electromagnet to offer immediate protection against short circuit. This electromagnet does not work under typical operating condition. But when there is a large overcurrent, usually from a short circuit, the magnetic field created by the higher current is powerful enough to instantly trip the circuit breaker and hence turn off the power. So this is how an MCB can protect our electrical system. Now let us understand some causes of insulation failure and hence how to get rid of it. So to get rid of such failure, we need to take some precautions. Use of quality materials and proper installation. So high quality materials must be used for long-term performance of the system. With proper installation method, high quality insulating materials suitable to the operating environment can protect us better than anything. The installer must ensure that he strictly follows the manufacturer's guidelines while installing the system. Next, protection device. Using surge protectors and other protective device to shield insulation from overvoltage condition. Moreover, the installer has to protect installation from extreme environmental conditions using enclosures or coatings. In addition to that, we have to check our grounding connections time to time to make it sure that the insulating is working perfectly. The principal reason for earthing is to try as much as possible to make sure that in any case sometimes goes wrong in an electrical system, the current's runaway potential energy has a quick, safe route through the ground without damaging any electrical equipments or any human. So in conclusion, when individuals and organizations appreciate the basic and significance of electrical earthing, it becomes easy for them to create a better electrical environment. So, as long as the regulations regarding the installation and uses in different environments are observed, the earthing system should work efficiently, minimizing any chance of electrical hazards in the number of places. After watching this video, now you should be able to answer the following questions. Thank you learners for watching this video.